Hello everyone and welcome back to Nunley Math. I'm your host Aaron Nunley. Thank you so much for joining me here today as we continue our study of factoring and how we can use factoring to solve polynomial equations. I do appreciate you being with us here today. As we mentioned in our last video, we are doing a few things just a little bit differently right now. We are currently here in Ohio under quarantine due to a virus scare. So we are doing a lot more of our classroom instruction online. So you're going to see some things that I don't normally include in our YouTube videos that are here just for my students. So if you're not one of my students, I do beg your indulgence on this because I want to make sure they get the information they need to be successful in class. Specifically, I am going to post the answers to the homework my students had last night. I'm not going to belabor the screen, but if you are a student in my class, I would ask that you do check over your work from last night. If you have any questions about these problems or how to do these problems, make sure you connect with me through our Canvas page and let me know so that we can touch base and we can talk one-on-one about those. So I'm going to assume you've paused the video, you've checked those, you've made contact with me if you need to do that. And then we're going to move on to what I would call a quick review. Once again, I'm going to suggest that you pause the video very quickly and spend just a couple minutes trying these problems on your own. These are things that you should have learned either in our previous lesson on solving equations in factored form or that you might have picked up in our study of polynomials and polynomial operations that we just recently completed. Again, if you are not a student in my class, you may want to try these. Otherwise, if you feel like you got a pretty good handle on this, you can skip these and move straight on into the lesson. I'm going to assume that those of you that wanted to try these have already done so, and I am going to go ahead and walk through these problems with you. Notice the first set of directions say factor out the GCF from each of these. In other words, in this quadratic trinomial, we're trying to see if there is a number that has been multiplied by all three terms. We're looking for a common factor for all three terms. Hopefully you can look at this and see that all three of these seem to have been multiplied by a 5. And when we factor, we just pull out that 5. We say, well, this must have been the multiplication problem, 5 times the quantity, x squared plus 2x plus 5. Notice if I use my distributive property and I pass the 5 out, I do get the 5x squared. 5 times 2x does give me the 10x, and 5 times 5 does indeed give me the 25. How about this next one? Were you able to find this one? I'm looking for something that it looks like all three of these terms have been multiplied by. Hopefully you can see that 14, 35, and 63 all have a common factor of 7, but notice this one has 3 x's, this one has 2 x's, and this has a single x, so all three of these have at least 1 x. So I'm going to factor out a 7x. Again, if I were to use my distributive property, 7x times 2x squared is 14x cubed, 7x times 5x is 35x squared, and 7x times 9 is 63x. How about down here? Solve each equation. Notice, excuse me, that I have an equation that is in factored form. It's in factored form because it is the product of several polynomials. Notice we have this monomial 2x being multiplied by the binomial 7x minus 3, and they equal 0. The zero product property tells me that if two things multiplied together equals 0, one of three things must be true. Either the first term or the first factor must be a 0 because 0 times anything equals 0, or the second term must be a 0. In other words, whatever this is, this times 0 would equal 0. Either way, whatever value of x makes these two equations true is also going to work for this factored equation. So if I want to get rid of this times 2, we would divide both sides by 2 and get an x equals 0. In order to get this x by itself, we would add 3 to both sides, divide both sides by 7, and you'd end up with x equals 3/7. In other words, if I stick a 0 in, I would get 0 times negative 3 equals 0. And if I stick 3/7 in, I would get 6/7 times 0 equals 0. These are the two values of x that would in fact make this equation true. If you had some difficulty with solving these single variable equations, you're certainly going to want to go back and review those lessons. We don't have time to do that here. Now this equation is not actually in factored form. I have to put it in factored form in order for us to be able to solve it. I'm going to do that by factoring out the GCF, just like I did in these steps. I'm going to look at this first term, 4p squared, and I'm going to look at this second term, the p, or you could think of this as 1p to the first if you prefer. I'm going to ask myself, what do these have in common? Well, 4 and 1 have a GCF of 1. P squared and p have a GCF of p, so I can factor out a p from this problem. Notice p times 4p is 4p squared, p times 1 is p. Of course, we have the minus sign in the middle. Now that it's in factored form, the zero product property says either the p must be a 0 or the 4p minus 1 should be a 0. Well, this left side is already solved. P is a 0. The right side, if I were to add 1 to both sides, divide both sides by 4, I would get 1/4. So if I stuck a 0 into this equation, it would be true. If I stuck a 1/4 into this equation, it would also be true. The last section just asks us to review binomial multiplication. Notice I have the quantity x plus 4, a linear binomial, multiplied by the quantity x to the first plus 3. This is a linear binomial. When we multiply those together, we learned that this x needs to get multiplied by both items in that second parentheses. X times the x is x squared. X times the 3 is 3x. I'm then going to take this 4 and multiply by both items in the second parentheses. 4 times x is 4x, and 4 times 3 is 12. Notice you have like terms in the middle. 3x plus 4x makes 7x. I'm going to do this next one a little faster. M times m is m squared. M times this minus 2 or negative 2 is negative 2m. I have a negative 7 times an m, and I have a negative 7 times a negative 2, which gives me a 14. Again, the middle terms are alike. Negative 2m minus 7m gives me negative 9m. And I'll do this third one just a little faster. Y times y is y squared. Y times negative 4 is negative 4y. 11 times y, 11 times negative 4. Combine your like terms in the middle. Last one. A times a is a squared. A times 5 is 5a. Negative 14 times a is negative 14a. Negative 14 times 5 is negative 70. Combine your like terms. Again, I did these pretty quickly. If multiplying binomials together is difficult for you, I would suggest you go back and watch, I think it's 2 or 3 videos prior to this one where we talk about multiplying polynomials. That certainly will be very helpful and handy for you. The reason I'm reviewing these today is because today we're going to use some patterns that emerge on these types of problems in order to unmultiply these polynomials. So for example, before you would take this linear binomial times this linear binomial and you would get a quadratic trinomial. In today's lesson, we're going to give you the quadratic trinomial here and see if you can figure out what binomials were multiplied together at the beginning. Here's a couple things that'll help us. First of all, if we have a quadratic trinomial, x squared plus bx plus c, and it is something that will factor. In other words, it can be written as the product of two binomials. There's a couple things we're going to note. First, the only way for us to get an x squared for our first term is if we have an x times an x. So we know this without any trouble. We also know that we're going to get plus signs in both of these spots. The reason for that is because two addition signs, when multiplied together, I should say two positive numbers when multiplied together, are going to give us a positive c. And two negative signs when multiplied together would also give us a positive c. So this positive c right here tells me that these signs must be the same. In addition to that, the only way I'm going to get a positive number in the middle is if those two are both positive. If they were both minus signs, you would get a negative b in the middle. Now, that's kind of a spoiler for this next example. If we have an x squared, we have to have an x times an x. And if we have a positive value for c on the end here, we know these signs are going to have to both be the same. Negative times negative would give us a positive c. Same as what we had here. In order to get a positive c, we had to have a positive times a positive. But notice this time we have a negative number in that middle position. That's because I'm going to have a negative number added to a negative number, and it's going to give me a negative answer. The third possibility for today is if you have x squared plus bx minus c. Notice that the third value has a negative sign in front of it, or a minus sign. Notice x times x is still going to be x squared, but when I go to multiply my last two items together, whatever this is times whatever this is has to give me a negative value. That means the signs will have to be different. When they were both negative, we would get a positive c. When they were both positive, we would get a positive c. If they're negative, the signs are going to be the same. And then I've just written out in words the things that we said just a second ago. In general, the sign in front of C, if it's positive, tells you that you will have like signs. And the sign in front of B tells you which of those signs you will use. If the sign in front of C is negative, then the sign in front of B helps you identify where the plus and minus will go. This will make a little more sense in just a second. Take this trinomial, for example. It's a quadratic trinomial. You have a quadratic term, a linear term, and you have a constant term. What I'm going to do is I'm going to try and split this into two binomials. A binomial multiplied by another binomial. In order for me to get an x squared, I know that when I multiply this together, I'm going to have an x times x, because that's the only thing that can multiply together to give me an x squared. The second thing I'm going to notice is that my last term, my c position, is going to be a positive number. Since it's a positive number, I know that both of these binomials are going to have the same sign. And so I look over here. This tells me they're both going to be positive. So I can fill those in. Now, here's what I know. When I do binomial multiplication, x times x is going to give me x squared. Then I'm going to take the x times this last number, and I'm going to write that down. I'm going to take whatever number this is times x, I'm going to write it down. And then I'm going to take these last two numbers and multiply them together, and they have to give me a 6. Now, there's only two possible combinations that will give me a product of 6. Either I have to have a 1 times a 6, or I have to have a 2 times a 3. Now, when I work this out, if this is a 1 and this is a 6, I'm going to get x squared plus 6x plus 1x. If it's a 2 and a 3, I'm going to get x squared plus 3x plus 2x. Only one of those is also going to give me a sum of 5. That's the 2 and the 3. In fact, if I were to plug a 2 and a 3 in, this would be the solution or the factored form of this trinomial. Notice, if I want to check my answer, x times x is x squared. X times the 3, lost my cursor, there it is. X times the 3 is my 3x. 2 times x, and 2 times 3. When you combine your 3x and your 2x, it does give you the 5x in the middle. Not too bad, right? Here's another one. Let's try this one over here. I'm going to try and split this into two binomials. I know, since it has an x squared at the beginning, that I have to have an x times an x. I also know that my signs are going to be alike because the last term, the constant term, is a plus. And I can tell you that they're both going to be positive because the middle term is a positive. So I know this has to be x plus something and x plus something. And I know these two things have to multiply together to give me a product of 12. There are only three choices. 1 times 12, 2 times 6, and 3 times 4. One of those must fit this solution. Now, the other thing that has to be true is when I have these numbers, they are going to have to add up to be 7. Well, 1 plus 12 is 13, 2 plus 6 is 8, and 3 plus 4 is 7. That last set gives me our correct combination, 3 and 4. And in fact, if I multiply those back together, x times x is x squared, x times 4 is 4x, 3 times x is 3x, 3 times 4 is 12. Notice that 4x plus 3x would in fact give me the 7x's in the middle. You may want to pause the video and try this one on your own. It is slightly different. I'm going to assume that if you wanted to do that, you would have already done that and that now you're checking your answer. Again, this is a quadratic trinomial. I want to split it into two binomials. And I know the only way to get x squared is x and x. I then look to see if my signs are the same or different. In this case, they're going to be the same. But when I check the middle term, this tells me they're both going to be minus signs. I then look at the 15. I say, okay, what things could multiply together to give me a product of 15? There are only two choices, 1 and 15, 3 and 5. But whichever one I pick has to give me a sum of 8. Well, let's see, 1 and 15 is 16. 3 and 5 makes 8. It must be the latter. And in fact, if I plug in 3 and 5, or 5 and 3, I'm going to get x squared minus 3x minus 5x plus 15. And notice those middle terms do indeed give me a negative 8. So I know that this is correct. One more like this, then we'll try something a little bit different. Again, if you wouldn't mind pausing the video, trying this on your own, I think that would be beneficial. If you're not going to do that, that's fine as well. Either way, I'm going to keep right on going. I want to split this into two binomials. The only way to get a squared is a times a. I look here and I see, oh, my signs must be the same. And I look here and I say, oh, they're both minus signs. I'm going to look over here at the 24 and say, what things could multiply together to give me 24? Well, 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Whichever one I pick, they also have to give me a 10 in the middle. So 1 and 24 is 25, 2 and 12 is 14, 3 and 8 is 11, 4 and 6 is 10. It must be the last one. And in fact, when you multiply this together, a times a is a squared. A times, don't forget this is negative 6 is negative 6a. Notice this is negative 4 times a. And this is negative 4 times negative 6, which is positive 24. If I were to combine my middle terms, negative 6a minus 4a is in fact a minus 10a. How'd you do? Pretty well? It's not too bad, right? Again, we're going to try and look at something slightly different. We're going to try still and break it into binomials. I still know I have to have x and x, but this time notice what happens. I have a minus sign or a negative sign on that last constant term. That tells me my signs must be different. And when I set this up, I'm going to end up with a negative 8. That tells me that the larger number is the one that's going to be subtracted. Now here's what I'm going to do. I'm going to go ahead and put in my plus and minus sign for the moment because I know they're different. You could have these switched. It really doesn't make a huge difference at this point, but we are going to make note of that here in just a second. Now this time I need two numbers that are going to multiply together to give me a 20. Or in fact, we could think of this as being a negative 20 because I'm going to have a minus sign. Well, there's only really three options for what could give me a 20. 1 and 20, 2 and 10, 4 and 5. Now, because this is a negative 20, I have to keep in mind that this could be negative 1 times 20 is negative 20, or it could be a positive 1 times negative 20. I don't know that yet, and at this point it's not terribly important. We are going to come back to that. But I want to think of how I'm going to get that negative 8. Remember, because there's a minus sign here, this is going to be a negative 8. But keep in mind that one of my numbers is positive, the other of my numbers is negative. So when I look at this 1 and this 20, I'm going to ask myself, does 1 plus negative 20 equal negative 8? Or does negative 1 plus positive 20 equal negative 8? Well, it's neither of those. negative 2 and 10, or 2 and negative 10. Now there's our right answer sitting right here. I'm going to come back to that in just a second. Negative 4 and 5, or 4 and negative 5. Obviously, this middle one is the right answer. We're going to have a plus 2 and a minus 10. So I'm going to put the 2 with the plus sign. I'm going to put the 10 with the minus sign. Now, students often ask me, what if we had put x minus 10 first and x plus 2 second? Well, that wouldn't have actually mattered because the two quantities are multiplied and the commutative property says we can switch the order. I'm going to give you one more of these to try. Again, I would suggest pausing this and trying it on your own before watching me do it. And then I'm going to point out a couple last-minute things before we wrap this up, okay? I'm going to assume that if you've wanted to try that, you pause the video, you've already done it. Again, there's only one way to get an m squared, and I know my signs are different. I can look over here and see the larger number is going to be the one that gets added. So I'm going to write my two signs in. I need things that multiply together to give me a 60. Well, there's a bunch of those. 60 and 1, 30 and 2, 20 and 3, 4 and 15, 5 and 12, 6 and 10. I believe that's it. Notice the more factors that this number has, the more choices you are going to have to pick through. Once I've done that, I'm going to look and see which of those things are going to add up to be a 7. Now keep in mind, one of them is going to be a positive and the other is going to be a negative. So things that add up to be 7. Well, negative 1 and 60 is positive 59. Negative 60 and positive 1 is negative 59. Negative 2 and 30 is positive 28. Positive 2 and negative 30 is negative 28. Negative 3 and 20 is 17. Positive 3 and negative 20 is negative 17. Negative 4 and 15 is 11. Positive 4 and negative 15 would be negative 11. And we can go through and look at all of these. There again, we've got the right one here, negative 5 and 12. Notice, since the 7 is a positive, I know the smaller number, the 5, is the one that's going to be with the minus sign. So I plug those in. Now, I do want to tie a couple things here together for you. There's where you can check your answer. And that's this. First of all, most students tend to find this first day of this to be not terribly difficult once they realize how to use the signs to help them. The big question I often get from my students is this. If we are doing a problem like this one down here and we find the correct answer, is it necessary for us to go through and write every possible combination out? Absolutely not. I'm listing them all out here for the video so that you can see the thought process that's going on in my mind. Remember, if you can spot the correct one more quickly, obviously you're going to want to do that. If you have trouble finding the correct one, then creating an organized list like this is a great way to make sure you're not missing something. Second, a lot of you are going to be able to look at these, especially the earlier ones, and you're going to be able to look at these and mentally come up with these. If you can spot these just off the top of your head and you can write them out and you can mentally check, you certainly don't need to make these lists at all. And a lot of times I'll actually do my check mentally. Early on, you may want to avoid doing this part mentally. You may actually want to write this out, but that's certainly a personal preference. One final thing is the trickiest part on this is making sure that you get your signs right. So please be very careful and double check those. And that really is about all there is to it. Don't allow the fact that these don't seem too terribly difficult to lull you into a sense of complacency when it comes to thinking through the process. I know what this is. I know what my signs are. I know which one's bigger. Make sure you at least walk through that process every time, because as we get into more and more challenging problems, that process is going to become much, much more important for you. Now, I do have one more slide here for you. These are just extra problems that I put in here to practice. I'm not going to walk through every single one of these with you. So if you want to work these out and try them on your own, I'd recommend pausing the video. I'm going to do them really quickly for you, just kind of show you what the correct answers are. If you're in my class, certainly you might want to send me a quick message if you're struggling with these. If you're watching me just on YouTube and you want to leave a comment in the comment section asking for some specific advice, I certainly can do that as well. One spot to be aware of, don't let the fact that I put an extra y squared down here throw you off. A lot of people get really frustrated by this y in the middle. Remember, there's only one way to get a y squared, and that is y times y. And when you take the x times the 2y, that's where you get that 2xy and the 3y times x, the 3xy in the middle. It helps if you put these alphabetically so that you can see them when they match. Students often struggle with that one. And then this last one over here, for example, f, if I were doing this, I would probably go ahead and rearrange this so that the leading coefficient or the coefficient of a 1 is first. Most people find that to be a whole lot easier when they go to break this down. If you were to do this as 15m minus n and 8m minus n, that certainly would be the same answer. And there's a lot of reasons for that I'm not going to get into here today. So hopefully that's a good start for you on factoring. Again, make sure you're walking through the process every time, even if you're just doing it mentally. Don't feel obligated to write out every single example. It's really not necessary, especially on these earlier problems where a lot of times you're going to be able to just look at these and see what the factors are very easily. If you struggle with finding what things multiply together to give you these numbers, don't forget there are some divisibility rules that you can go back and review that may help you with trying to sort out what your options are. Again, that's all I got for today. Hopefully that wasn't too tedious for you. Thank you so much again for watching. Again, if you're a student of mine, send me a message if you have any struggles. If you're not a student of mine, you can leave a comment for me and I'll try and get back to you just as quick as I can. Thank you guys very much for watching. Best of luck to you guys. Everybody stay safe out there, all right? Take care of yourselves. Bye-bye.